Hello everyone, my name is Alexis Swanson and the title of my final project is using Sentinel-2 images to determine the impact of Hurricane Florence on the Neuse River in Clayton, North Carolina. Starting with my two research questions, my first is, how much flooding did Hurricane Florence cause in the Neuse River? And the second is, did any of this flooding impact urban areas? Both questions I am asking are spatial in nature and are important in evaluating the damage Hurricane Florence caused. This information on a wider scale could be used to predict future impacts of hurricanes. The data I obtained for this project came from the Sentinel-2 satellite. I gathered an image from pre, during, and post-hurricane, as you can see here, with dates of imagery as September 6, September 18th, and September 26, 2018, respectively. The main focus of this project was the four 10-meter bands. 60-meter bands are also a part of this data set. My data source was Earth Explorer, which is from the USGS, and there is available metadata on the Earth Explorer website as well as the link shown here. The main spatial analysis method used for my project was a supervised classification. This analysis was chosen because it could answer the research questions by quantifying the number of pixels that were classified as water for each image, and therefore it could be determined if there was flooding during the hurricane. This involved creating training samples for the four land cover classes in the image. Water is blue, vegetation is green, agriculture is yellow, and urban is red. The image with overlaid training polygons is shown here. This flowchart represents the flow of my analysis. It started by gathering the data from the Earth Explorer website, then creating a new project, adding the data to the map. Then the image needed to be prepared for processing by creating a composite image using bands 2, 3, 4, and 8, and clipping the image to the area of interest. The next step was the supervised classification, which also involved two steps. First, creating a new schema of land classes, and then creating at least 20 training samples for each class. This step was shown in the previous slide. After this analysis was run, we needed to calculate the number of pixels for each category and calculate the percent area for each land class. This was done by creating a raster attribute table to get the number of pixels and using the total number of pixels to get the percentage by creating a field in the attribute table. This process was followed for all three images, pre, during, and post-hurricane. Here we have the supervised classification results for each image. From left to right is the pre, during, and post-hurricane images. Again, blue represents the water, green is vegetation, yellow is agriculture, and red is for urban areas. As you can observe, there is an increase in width of the Neuse River during the hurricane that subsides again for the post-hurricane image. This represents the flooding that occurred. From these images, it does not appear that any urban areas were impacted by the flooding. One thing to note is the disruption of the Neuse River in the last image. This was due to a shadow that was cast in the image, causing those pixels to be classified as vegetation rather than water. This table represents a summary of key results from each of the attribute tables. These numbers show the increase of water pixels during the hurricane and the associated percent area covered by water. The difference in pixels from pre to during was 56. Since the pixels have a 10-meter resolution, it is approximated that this difference equates to a 560-meter increase in water coverage during the hurricane. Note that this is an approximation. Like previously mentioned, the shadow disrupted the Neuse River in the post image, but the numbers still show that it returned to a base flow. To summarize our key results, we were able to see visible flooding on the Neuse River and approximately quantify this flooding. This is consistent with our expectations. To answer our other question, we did not see any flooding of urban areas in this particular reach. This is not to say that there is not flooding of urban areas from Hurricane Florence in other reaches or other rivers. There are some opportunities, as with any project, for improvement. First, while we were able to approximate the flooding, a higher spatial resolution image, such as 2 meters, would provide a more detailed look. Oftentimes, this is costly to get a 2-meter resolution. Additionally, this project only looked at one small reach of the Neuse River. To get a holistic look, it would be ideal to choose random samples throughout the entire region to get a better representation.